My name is Rahab Sawah, and I'm an associate professor of physics at St. Louis Community College at Florissant Valley, where I also teach astronomy. My love for the sciences led me many years ago to learn about the history of how these sciences developed, and eventually I completed a graduate degree in history at the University of Missouri, St. Louis. And the work that I did in history, as I actually learned about the history of sciences, was to focus specifically on the history of astronomy. And I actually found a smaller niche in the history of the development of astronomy, which is really Islamic astronomy. And so you can look up my thesis, my MA thesis from the University of Missouri St. Louis. It's archived electronically on their website, and it's titled The History of the Observatory as an Institution from Moraga to Mount Wilson, these two famous observatories. And the title of the presentation today is about Islamic and Arabic astronomy, and so this is really a name that is really hard to pin in terms of its accuracy, and let me tell you a little bit about that. When we talk about Islamic astronomy, it's really astronomy that developed during the Islamic era, and that means it was not actually only developed by Muslims and Christians and Jews and anyone from any different religious background would have contributed to these sciences, not just astronomy at the time period, but also when we talk about Arabic astronomy, it's really referring to the same astronomy, but the fact that it was developed during the Islamic era, the official language of that time period was Arabic. And so often you'll read in history books on science reference to Islamic science or Arabic science, and they really are both referring to the same thing, even though, as I said, it's not only Muslims who participated in this work, and it's not only Arabs who participated in this work. So if someone's, let's say, mother tongue at home was Persian or Turkish or Kurdish or any other ethnicity, or Chinese, as some of course spoke when they came from China to some of the observatories that were built and so on, they actually spoke a different mother tongue at home. However, when they actually participated in public life and published work, it was done in the official language of Arabic at that time period. Just like people who come to the U.S. to study today, well, everyone has to publish in English because that's the official language, even if they went home and spoke a different language at home. And so the name Islamic and Arabic I will use interchangeably throughout the presentation today. And remember, I'm not referring only to Muslims, but actually the work done during the Islamic era, and I'm not referring only to Arabs, but work that was published in the Arabic language. So let's take a look at this map that shows us the distribution of Muslims since we're talking about the Islamic era. A lot of people think Muslims and Arabs are the same thing. In fact, Arabs are really a minority in the population of Muslims around the world. If you look at the distribution of Muslims in different countries around the world, you can see how those countries highlighted in the white are the largest concentration of Muslims in them. In fact, they are Islamic countries in that regard. And we're going to be hearing about countries such as Azerbaijan. We're going to be hearing about Iran, which used to be Persia, in the presentation today. And you're also going to be hearing about Uzbekistan, amongst other ones in the presentation. So that you know where these countries geographically sit on the world map today. And we'll also hear about, obviously, Syria and Iraq and some Morocco and eventually Islamic Spain, which I will refer to in just a minute. But the largest concentrations of Muslims in the world today is actually in the country Indonesia, with a population of Muslims of about 210 million out of 250 million in Indonesia. And the second largest concentration of Muslims in the world is in India, Current day India houses about almost 175 million. But if you look at what would be referred to as historic India, if you may, so that would include current day Pakistan and India, the population of Muslims in this part of the world is actually more than Indonesia. It's almost close to 345 million. And India actually is the second largest region where there is a largest concentration of Muslims in the world after Indonesia. Arab Muslims make up only 18% of Muslims in the world. And of course that means Arabs are not only Muslims, but they're Christians and Jews, of course. And if we look at how the Islamic Empire once spanned on the world map, you'll find out that it went as far east as Western India, and it spanned all of southwestern Asia, this region and this corner of the western side or part of Asia, the southwestern part, and all of North Africa into Islamic Spain, also known as Al-Andalus in Arabic, or Andalusia, or Andalusia in English. You might also know it as Islamic Moorish Spain. So all of that was actually part of the Islamic Empire, and this actually was the map of the Islamic world, or the Islamic Empire, as early as the 7th century AD. And remember, I said Arabic was the official language that actually united all of these regions where everyone published in Arabic. It doesn't mean they can't publish in their mother tongue, but if it were actually published, if there was an official publication, it would have to have happened in Arabic. So, if you look at any textbook in astronomy, as I often do because I teach astronomy, you would find out that there is mention of the ancient Greek astronomy, naturally speaking, and that of course happened between about 500 BC to 200 of our current era. And then there is this big giant leap all the way to the Renaissance. So we're talking the 15th century of the current era, as if what existed in between was a total scientific desert, as if nothing happened in between. And if you have studied sciences, or if you know someone who has, they can tell you that science is not developed in that fashion. There aren't these big giant leaps just out of the blue all of a sudden, where you have new theories that evolve out of thin air. It does not happen that way. Ideas actually build incrementally on top of each other, even though some historians of sciences talk about a paradigm shift, but still the paradigm shift builds on previous ideas that came. And so if we go back as far as Aristotle, who lived in the 4th century BC, we have the first geocentric model of the heavens, basically, and where Earth is at the center, and all of the moving objects that we see in the sky revolve around planet Earth. The Aristotelian model itself is actually an evolved model from earlier ones in the Greek era, but the Aristotelian one is the one we usually go back to refer to the geocentric model. And that's the one that Ptolemy, of course, inherited by the 2nd century AD, and actually added some of his mathematical models to, in order to make it a model such that if you would calculate the positioning of the planets and you matched that to the observations, they would actually coincide very well. So let's talk about the planets that were observed at the time. They didn't have telescopes, not until Galileo, so they could only see Mercury, Venus, Mars, Jupiter, and Saturn, so that's 5 planets. And on top of that, the other 2 wandering objects in the sky were the sun and the moon. And so the 7 heavenly objects, as I'm going to refer to them from now on, were really the ones that astronomers tracked throughout the centuries and created astronomical tables for. So if we go back to the earliest complete records of astronomical tables of the planets, we actually find that these were the Babylonian records. And that's actually, these are the records that the ancient Greeks inherited from the Babylonians who lived in the 17th century BC. And so they were great record keepers, the Babylonians were, and the ancient Greeks were so thankful that the Babylonians actually did that. And these were actually the records that, up until the Ptolemaic era, were used, in fact, to derive the models, the mathematical models, to predict if these planets are going to be in these locations at this time period or a later time period. Now you might say, well, why do you think those people were interested in predictions? Well, for many reasons. Astrology was a very important thing for the ancient Greeks, as to many peoples before them and after them, really until the current era, but not necessarily to scientists today, but back at that time it was actually important. And if we take a look at the Ptolemaic model, which is the most latest Greek model that has come down throughout the millennia, or actually throughout the centuries, from one part of the world to another, we would actually find the Ptolemaic model. Now, Ptolemy's model was translated to Arabic, and that's because, remember, Arabic was the language of science during that period. And if you take a look at this slide, you will actually see one page of many of what became known as Ptolemy's Almagest. Almagest is the Arabic word of Al-Majasti, and which means the Great Compilation. It's Ptolemy's Great Compilation. And it was actually this compilation that was translated from ancient Greek to Arabic during the Islamic era. The Muslims were actually very interested in the sciences that came before them. If we arrive at the Abbasid Caliphate, that era that started from the 8th century and spanned all the way to the 16th century, we see at the very beginning of the Abbasid era massive translations from the ancient Greek of every works they can get their hands on, whether it's in the sciences or in philosophy. Anything that they can actually grasp was translated into the official language of Arabic. And remember, this was an endeavor that happened where Muslims and Christians and Jews, everyone participated in this endeavor. As the translations were made, they were actually also compared with actual observations of that time period. So a lot of history of science books talk about the Arabs, again, as we say Arabs, meaning people who spoke Arabic or wrote in Arabic, not necessarily Arabic themselves, because they could be of other ethnicities. They refer to, historians of science have often referred to the Arabs as mere translators from the ancient Greek sciences into Arabic, which eventually all of ancient Greek science that was translated to Arabic made its way to Latin around the Renaissance era. But what these astronomers in this time period, so Muslims, Christians, Jews who published in Arabic, Arab astronomers, what they would actually do is they would compare what they're translating to actual observations at the time. Now remember, the Greeks inherited the observations that were by the Babylonians, so that's the 17th century BC. And now we're talking at the time of the 8th century AD, so that's what, almost 2,500 years later. Well, our planet precesses about its axis, just like a top. If you take a top and you spin it and you watch the axis of the top do this precession motion as it actually turns around, as you actually allow it to spin on a table, our planet does the same motion. It takes about 24,000 years for it to do one full precession cycle. But in 2,500 years, you would not have these planets be positioned exactly in the same locations as they were 2,500 years later. And the Arabs noticed that, and so they actually began to scrutinize these astronomical tables. Ptolemy's Almagest, for sure. I mean, it was great work that he did, and they definitely appreciated it, and it still remained known by its Arabic name, never its ancient Greek name. So we begin to see after this massive translation new astronomical tables coming into existence. So here's an example of one that came later on, actually. This was in the 15th century in the city of Samarkand, which is in current days Uzbekistan. Remember, this is further east in Asia. And this was actually published by Ulugh Beg. And Ulugh Beg, he was actually a ruler from the Timurid dynasty. He lived and ruled in the 15th century. And yes, he was actually the ruler, the supreme ruler, yet he had a love affair with the sciences, and so he was an astronomer and a mathematician himself, and he decided to observe the stars and the planets and to record his own data, publishing his own scientific table or astronomical table, which was at the time known as Zij. Zij is an astronomical table. And what you would see actually on one side is the work by Ulugh Bey on the right page. On the left page is a Latin translation of it. And this was actually the translation that was used by Flamsteed in the 17th century in England. And Flamsteed actually was the first astronomer royal at the Royal Observatory of Greenwich in England at the time in the 17th century. So about 1675, Flamsteed was then the astronomer royal running that observatory at Greenwich. And he actually used the work by Ulugh Beg. As you can see, on one side was the Latin, on the other side is Ulugh Beg's actually Zij, or astronomical tables. And so we begin to see later on in the Renaissance the use, the Europeans not just going back to ancient Greek, but also recognizing that those ancient Greek tables were not accurate and finding more accurate tables that were published by the Muslims in later centuries. One of the earlier astronomers that actually created astronomical tables from his own observations is Al-Battani. Al-Battani lived in the 9th and 10th centuries, and the historian Will Durant, who wrote and I believe it was an 11-volume publication that was titled The Story of Civilizations, that began to be published in the 1930s. He writes about Al-Battani and says that the astronomical observations that Al-Battani did continued for 41 years. Now, you might say, that's a long time. Yes, absolutely. But if you consider the length of time that planets take to revolve around their orbit once, the longest planet that was available to the ancients to observe, actually, and record its movement in the sky is planet Saturn. Saturn takes almost about 30 years to finish one full cycle along its orbit. So if Al-Battani observed the planets for 41 years, he would have captured Saturn from being at one position in the night sky, changing for almost 30 years and arriving back at that same position at that same time at night, almost 30 years later, one full cycle of Saturn. So that would give Al-Battani the advantage to actually do a whole bunch of other calculations, which he did, because not only were his observations so accurate, here's someone who was very picky, probably you would call a perfectionist, but he was very accurate in his observations. The ranges were very close to exact as today's, and on top of that, he actually determined many astronomical coefficients. These are constants that show up in equations that are remarkably close to the current modern calculations. So the work by Al-Battani was quoted by many people in the Renaissance, such as Copernicus, Johannes Kepler, Tycho Brahe, Galileo. They all quoted this astronomer that existed and lived about 700 years before Galileo.